My name is Jim Al-Khalili, and I'm a professor of physics at the University of Surrey. Studying the innermost secrets of atoms and their nuclei has been at the heart of my working life. But there's another side to me. I was born and grew up in Baghdad to an English mother and Iraqi father, but left Iraq with my family in the late 70s when Saddam Hussein came to power. By then, science was already my great passion in life, and as I studied it further, I saw myself fully part of the Western tradition, inspired by names like Newton and Einstein. But buried away was this nagging feeling that I was ignoring part of my own scientific heritage. I still remembered my school days in Iraq and being taught of a golden age of Islamic scholarship, that between the 9th and 12th centuries, a great leap in scientific knowledge took place in Baghdad, Damascus, Cairo and Cordoba. So I want to unearth this buried history, to discover its great figures and to assess exactly what their contribution to science really was. Are there medieval Muslim scientists who should be spoken of in the same breath as Galileo or Newton or Einstein? And crucially, what is the relationship between science and Islam? My journey into the science of the medieval Islamic world will take me through Syria, Iran, and North Africa. I started in the back streets of the Egyptian capital, Cairo, with the realization that the language of modern science still has many references to its Arabic roots. Take scientific terms like algebra, algorithm, alkali. I instantly recognize these words as Arabic. And these are at the very heart of what science does. There will be no modern mathematics or physics without algebra, no computers without algorithms, and no chemistry without alkalis. Surprisingly few people in the West today, even scientists, are aware of this medieval Islamic legacy. But it wasn't always so. From the 12th to the 17th century, European scholars regularly refer to earlier Islamic texts. I have here copies of some pages of the book Liber Abaci by the great Italian mathematician Leonardo Pisano, otherwise known as Fibonacci. What's fascinating is that on page 406 is a reference to an older text called Modum Algebra et al-Muqabala, and in the margin is the name Mahomet, which is the Latinized version of the Arabic name Muhammad. The person he's referring to is Muhammad ibn Musa al-Khwarizmi. In fact, Arabic names crop up in many medieval European texts on subjects as varied as map-making, optics, and medicine. But I want to start with al-Khwarizmi because his work touches on a crucial aspect of all our lives today. It's thanks to al-Khwarizmi that the European world realized that their way of doing arithmetic, which was still essentially based on Roman numerals, was hopelessly inefficient and downright clunky. If I ask you to multiply 123 by 11, you may even be able to do it in your head. The answer is 1,353. But try doing it with Roman numerals. You'd have to multiply CXXIII by XI. It can be done, but trust me, it's not fun. Al-Khwarizmi showed Europeans that there's a better way of doing arithmetic. In his book entitled The Hindu Art of Reckoning, he describes a revolutionary idea. You can represent any number you like with just 10 simple symbols. The idea of using just 10 symbols, the digits from 1 to 9, plus a symbol for 0, to represent all numbers from 1 to infinity, was first developed by Indian mathematicians around the 6th century AD. And I can't overstate its importance. Let me show you. Here are the numbers in Indian Arabic numerals. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here are the numbers we're more familiar with in the West. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see the similarity between these numbers, in particular, for instance, the digits 2 and 3. If I tip this sideways, you can see now how they look like numbers 2 and 3. And what's powerful about these digits, this numerical system, is how it's simplified arithmetic calculations. But Al-Khwarizmi and his colleagues went further than just translating the Indian system into Arabic. They created the decimal point. This text, written a century after Khwarizmi, is by a man we know only as Al-Uqlidisi. Here he shows that the same decimal system can be extended to describe not just whole numbers, but fractions as well. The infinity of possibilities that lie in between the integers. Here's a copy of Al-Uqlidisi's manuscript where he showed how the decimal point is used for the very first time. He describes it by using a dash. Here are the digits 1, 7, 9, 6, 8, and you can see there's a small dash over the 9 indicating the decimal place. The idea of the decimal point is so familiar to us that it's hard to understand how people managed without it. But like all great science, it's blindingly obvious after it's been discovered. The story of numbers and the decimal point hints that even over 1,000 years ago, science was becoming much more global. Ideas were spreading, emerging out of India, Greece, even China, and cross-fertilizing. And looking on a map that shows where people lived 1,000 years ago gave me my first insight into why medieval Islam would play such an important role in the development of science. Now look at which city lies at the center of the known world, a place where the widest range of peoples and ideas were bound to collide. It's the city where I was born, the capital of the Islamic Empire, Baghdad. Recent events mean I can no longer visit the city. But these are the home movies of my cousin Faris, filmed in the 1960s. The Baghdad we knew then looked nothing like the bomb-wrecked city it is now. I certainly grew up proud to be associated with one of the world's greatest cities. Baghdad was founded in 762 AD by the Caliph al-Mansur. His aim was to make it the glorious capital of a brand new empire, united by Islam, the rising religion of the time. The Abbasid caliphs had claimed their right to rule by declaring that they were directly related to the Prophet Muhammad, who had founded the new religion over 100 years earlier. But in that short time, the army